Hi class, and welcome to video lesson synthetic division notes day 3. I still don't have a voice, so I am very sorry for my voice sounding gross like this, but it is what it is, and we're going to do the notes anyway. We actually already did this warm-up problem, so I'm not going to make you do it again, but we did this warm-up problem right here. So we're going to skip the warm-up for today, and we're going to dive right in to synthetic division day 3. And this is where we throw in the quadratic formula. So yes, you need to know the quadratic formula still this semester. Okay, it says find all of the zeros, including irrational zeros. Irrational zeros occur when the trinomial that's left over does not factor. Okay, so we're going to start this out the same way. We're going to put 1 in the window. Oops. And we are going to do synthetic division. 1, 4. There is no linear term. I'm going to put a 0. And then -5. So we drop down the 1. 1 times 1. 4 plus 1 is 5. 5 times 1. 0 plus 5 is 5. 5 times 1, and we know this is a 0, so the remainder is 0, as it should be. The resulting quadratic is x squared plus 5x plus 5. Okay, and this is not factorable. There's no two numbers that multiply to 5 that also add to 5. So what this means is it's not unsolvable, we just have to use the quadratic formula to solve. So there's irrational solutions. So the quadratic formula is x equals, I'm going to write it up here, opposite b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to get really fancy. There's the quadratic formula. Okay. So opposite b is going to be -5 plus or minus the square root. B squared will be 5 squared minus 4 times 1 times 5 all over 2 times 1. Okay, I'm going to put this part in my calculator. Oh boy. Let's get my calculator. Sorry about that. And I get 5. Wow, 5 is just the magic number here. I guess I could have done that in my head. What do you guys think? Probably. That's okay. This is actually the answer. There's nothing else I can do here to simplify. So let's write out all the zeros. There's 3 of them. There's -5 plus root 5 all over 2. -5 minus root 5 all over 2. And the original 0, which is 1. Now this is one way to do it, but I would also accept you writing out -5 plus or minus root 5 over 2. Just understand that this is 2 answers. This is these 2 answers written together with this plus or minus symbol. Okay, so I would also accept this as long as you understand that the fraction here is actually 2 answers. All right, so what if there's imaginary zeros? Okay, there is a fun fact about imaginary zeros. This is actually also true with irrational answers. The only way to obtain an imaginary answer is by doing the quadratic formula. or complete the square. But when we do that, you end up with a plus or minus answer. So because you end up with a plus or minus, what's called the conjugate theorem comes into play. So if I have an imaginary answer, of I, then what that means is negative I is also an automatic answer. So all you do is change the sign of the imaginary part. So if 1 plus 3i is a 0, what that means is 1 minus 3i is also a 0. Again, because the only way to get this answer is for it to be like this, 1 plus or minus 3i. Okay, so negative 2i and positive 2i would both be zeros. 4 minus I, and then 4 plus I. Okay. Let's do the next example. Find all the zeros. All right, we have 2i is a 0. All right, let's do our synthetic division. 1 times 2i is 2i plus negative 5 is negative 5 plus 2i times 2i. We have to distribute. So 2i times negative 5 is negative 10i. And 2i times 2i, I'm going to write it out here. I'm just distributing. So 2i times 2i is 4i squared, but I squared is negative 1. So it's negative 4 minus 10i. What's interesting is that, look, these negative 4's cancel. So I get negative 10i times 2i is negative 20i squared, but I squared is negative 1. So that changes this to a plus, and that means that this is a 0. Because of the conjugate theorem, I know that negative 2i is also a 0. So I can put that in a window and do a double-tiered synthetic division like we talked about yesterday. So again, if 2i is a 0, then negative 2i is also a 0. So I'm going to do a double-tiered synthetic division to get all of my zeros. So 1 times negative 2i is negative 2i. And what's really nice about this is things should cancel nicely. Negative 5 times negative 2 is positive 10i, which cancels. What I'm left with is, remember, this is my constant and this is my linear. So I'm left with x minus 5, which means my last 0, just get x by itself, is 5. So the zeros are 5, 2i, and negative 2i. Okay, I'm going to skip example B for now. We can regroup and talk about it on Monday. It's a long weekend, so Tuesday, actually. We're going to move on, excuse me, to writing this equations. All right, find a polynomial with a equals 1. That's really important. That has these zeros. This is actually pretty simple. So if x equals 0, x equals negative 4, and x equals 2, let's list out the factors. If x equals 0, the factor is just x minus 0, which is just x. If x equals negative 4, move this back over to get the factor. It's x plus 4. Move this back over it's x minus 2. But then this. A multiplicity of 2 means that that factor is squared. If it was a multiplicity of 3, then it would be raised to the third power. Okay, we have to FOIL this all out to get our final answer. Here's how I would do it, personally. It doesn't matter what order you do this. So I would do this. I would FOIL this because it's a little bit easier. It's x squared minus 2x combines to minus 4x, and negative 2 times negative 2 is positive 4. I'm going to pause that, and I'm going to take this and distribute this x. So we get x squared plus 4x. And now I'm going to FOIL these two answers out. So x to the 4th. So take this x squared and distribute it to everything in the trinomial. X squared times just 4 is 4x squared. And now we're going to take 4x and multiply it. So that is positive 4x cubed. 4 times negative 4 is minus 16x squared. And 4 times 4. So here's my final answer. The x cubes cancel. Here's what this means. If I take my answer and I put it into Desmos, x to the 4th minus 12 x squared, sorry, it took me a second to remember it, plus 16x. My zeros should be what they gave me. So notice that my zeros or my x-intercepts are negative 4, 0, and 2. And on top of it, 2 has a multiplicity of 2, which we can see through the fact that it's a bounce point. So the function bounces off the 2 and goes back up. So I know I did it right. Okay, now notice that this said a equals 1. Sometimes a doesn't equal 1. And so that's going to be with example 4. And this is going to be the last example I'm going to do today. I will talk about example 5 when I see you next. So for this one, my zeros are negative 1, 2i, and it's not listed, but if 2i is a 0, then negative 2i is also a 0. This is going to be really important, so I cannot assume that a equals 1. So here's what happens in that scenario. First, let's write the factors. Okay, writing this factor is difficult, so I'm going to teach you a trick. Here's the trick. If x equals 1, plus or minus 2i, okay, here's something that you can do to write the factor. Instead of just moving this back over, what you can do is square both sides. Here's what we get. X squared equals 2i times 2i is 4i squared, which is negative 4. And then move this over. So the factor that gives me 2 plus or minus 2i as the 0 is actually x squared plus 4. Now I'm going to write down x plus 1 and just FOIL this out. There is another way to do this. The other way to do it would be this. And then FOIL all that out. But I like this trick. Okay, FOIL. X cubed plus x squared plus 4x plus 4. And what I kind of forgot to do, which don't worry, we can still do it, is this. I also know that f of 2 is 12, which means there might be a lead coefficient. So if there is a lead coefficient, I have to put an a in front of all of this, which is totally fine. I don't have to worry about the fact that I just worked ahead. I'm going to come back to that red answer in just a second. But before that, I'm going to find A. And I suggest doing it before you FOIL it out. So here's how you do it. If f of 2 is 12, then what you can do is this. 12 equals A times plug in 2 for x. And it's easier to do it in the factored version. Okay, we get this. 2 plus 1 is 3. 2 squared is 4. 4 plus 4 is 8. So we get 12 equals 3 times 8 is 24a. And divide over 24. So 1/2 equals a. All right, so here's my final answer. You do need to take this 1/2 and multiply it, distribute it to your FOILed answer. So like I said, I worked ahead, but it wasn't something that I needed to erase because I did need to do it eventually. I just had to distribute 1/2. So here's my final answer. 1/2 x cubed, 1/2 x squared, half of 4 is 2. And half of 4 is 2. So this should be a polynomial that has the zeros, -1 and plus or minus 2i. But also, when I plug in 2 for x, my answer is going to be 12 now. And I made sure that happened by doing this step. So it's a lot of information, but we are luckily going to be able to come back. Look at the calendar on Tuesday and revisit some of this, okay? We're going to move on to do one more thing before we review for the unit. So that should be that. Feel free to go back and rewind, rewatch, and come with questions on Tuesday.